is exactly what the central limit theorem states. It states that if you take any population distribution, the sample average will have our normal distribution for large N. Also, like you could ask, where does the law of large numbers come up? And that's basically telling us this thing. So, law of large numbers is that I guess it's a weaker theorem than this. It says x bar is a good approximation or a good estimate for mu if n is large. Okay. So any questions about chapter 11 stuff? So this is these are the main things to know. I mean, if you only remember one thing from chapter 11, it should be this formula here, basically. It's the most important thing. All right. So let's move on then to chapter 14. So chapter 14 is where we started talking about confidence intervals. Actually, I'm going to talk about all the different ways we have of computing confidence intervals at once. So this is 14/18. Right? So we have the following formulas for confidence intervals for mu. And we're going to have a different formula depending on whether we know what sigma is or whether we don't know what it is. Okay? So if sigma is known, then we use the one that we learned in chapter 14, which is x bar plus or minus z star times sigma over root n. So again, this is from chapter 14. So if sigma is known, we use this one with the z star. If sigma is not known, so if we're missing this piece of information, we get a slightly worse confidence interval. It's going to be a little bit wider. And the formula is x bar plus or minus t star times s over root n. Okay, we're here. S is the standard deviation of your sample.
On the exam, would you explicitly tell us if sigma was present and was not present?
Yeah. So so on the exam, right? If I say sigma equals whatever, that's how you know that you use this. If I don't give you a value for sigma, that means you need to use this.
Are we going to be calculating the standard deviation?
Yeah, you should know how to compute these standard deviations.
In the test we will be.
You should know how to do it. Yeah, you can use your calculators for the test.
But wait, would it be within 3 or 4 points rather than 9?
Yeah, I'll never give you So, yes, let's go over these Z stars and P stars. So the thing to know about Z star and P star is Z star depends only on the confidence level which is capital C. P star depends on the confidence level as well as the degrees of freedom that you have. So it's on C and on the degrees of freedom, which are just equal to n minus 1. So yeah, so let's do an example of computing these things. So let's suppose I'm studying penguins, and we want a say 95% confidence interval for the mean weight of all emperor penguins. Okay. So to do this, we need to collect some data. Take a boat to Antarctica and measure some penguins. And so suppose we get the following numbers. So we sample 10 penguins, and we get sample mean of, let's say 33, with a sample standard deviation so S equals 1.7. Okay. So this is the whole setup. So the first question is, do we use the t distribution or the normal distribution for this one?
T.
T distribution. And why do we use the t distribution?
We don't know sigma.
Yeah, we don't know sigma. We only have s. So use the t distribution since sigma is unknown. Okay, so our formula is x bar plus or minus t star times s over root n. Okay, and now what's x bar in this problem? It's 33. What about s? So it's 1.7 we have over here. And what's n?
Square root.
It's the n is the 10 penguins. So all we have to do now is find t star, and we can plug that into this formula. So what's t star? So for that we need our confidence level, C. So what's our confidence level? 25%. We also need the degrees of freedom. What's that going to be? Right? Okay, so now that we have these two numbers, all we need to do is look at our t-distribution table. So table C tells us, if you look at this 95% column, and we go down to row 9, we get 2.262. Okay, question?
So will you always give us like a relative sample size so that it's on that chart? Like you won't give us like the degrees of freedom won't be like 35 or something where it's not.
Oh yeah.
Or like,
Yeah, so on the exams and stuff, I'll always give you a degree of freedom that's on this table.